Again, today we're looking at standard form. We're looking at the standard form of an equation, standard form of a line. So the standard form of an equation has something and something on the same side of the equation. Okay? It's kind of an interesting thing to have here. Standard form is actually written this way. It's ax plus by equals c, where a, b, and c are some sort of coefficients. They could be positive, they could be negative, they could be fractions, they could be decimals. That is gross. What happens with this in comparison to what we talked about last time, where we had y equals mx plus b? What is on the same side that we can conclude for standard form? What's on the same side? Yeah, x and y. Both your x and y, your two variables that we're really talking about, are both on the same side of the equation. Now, generally speaking, there's two ways that you could do this. Since we're doing an algebra review, there's an algebraic approach where basically which is what we're going to do today, is we're basically going to solve we're just going to solve each and every single one of them for y, and then we're going to basically do exactly what we did on Friday, which is one method. The other method is you can actually just use these and find the x and y intercepts, the x-intercept and the y-intercept. You can plot those 2 points and draw a line through there, which is one method for this, which I think we did earlier this year, and probably you made use of last year if I remember correctly. So the goal here is that instead of that, we're actually going to change standard form to slope-intercept form. In order to graph the equation. So we're going to change standard form into slope-intercept form in order to solve the equation. The method is below. There's 3 steps for it. The first step just says move the x term to the other side of the equal sign, basically subtracting b from both sides or adding it to both sides. You'll divide the coefficients by the y term, or basically the number in front of it, which is the b. And then we follow the steps for slope-intercept graphing. So there's always going to be a little bit of room provided. So when you look at this problem, it starts up here, and this is the graph for it. It's not whatever numbers are down here. This is not whatever your graph is. Your graph is the one that's above it. Okay? So for instance, this very first one, what we'll do is we'll actually subtract x from both sides. We'll have y equals negative x plus 5. And that's now in slope-intercept form. Generally speaking, it's not always that easy. Sometimes it is. But generally speaking, it's not going to be that easy every single time. From there, what we need to do is we need to graph this. So how do I graph this from slope-intercept form? Yeah, we go up 5, so 1, 2, 3, 4, 5. We go up 5 because this is the y-intercept, which is 5. Our slope is negative 1, so we'll go down 1, right 1, down 1, right 1, down 1, right 1, until we fall off the page, which looks like that. And then we'll also use the opposite slope, which is up 1, left 1, until we get off the page, like so. We'll use our rulers or straight edge in order to draw a straight line through each of these points. Okay, so it takes a little bit of algebra to start off with. It takes a little bit of algebra to start this process off with, but then we should be okay. Yes, Sam? Okay, so the process of graphing is going to be the identical to slope-intercept form that we talked about last week, because we actually put the equations into slope-intercept form. Katie, how do we solve the second one for y? So since it is a positive 2x, we'll actually subtract 2x from both sides. So what do we get? That's perfect. Our y-intercept is 4, so what do we do there? 1, 2, 3, 4, so that's right there. And what does the negative 2 mean? We go down 2 over 1, down 2 over 1, and we'll continue doing that until we're off the page, like so. And we'll also use the opposite slope, so it means we go up 2 and left 1 until we're off the page. Should look like this. We'll draw a straight line through each of these points, and we should be good. Is everybody okay with this method so far? Does anyone have any questions besides, why did my graph not get copied all the way? Okay, the third one. We are going to solve for y, so what do we do first? Yeah, we're going to add 3x to both sides. Since the 3x is negative, we have to add 3x to both sides. We'll have negative y equals positive 3x plus 5. Now, this says something like the opposite of y is 3x plus 5. We actually want to solve for y itself. We could actually divide each term by negative 1 or just use the idea of opposite. If the opposite of y is this stuff, then y is going to actually be the opposite of these pieces. So negative 3x minus 5. That would be the opposite of each of those pieces. So because it said the opposite of y is 3x, that means that y would have to be negative 3x. Because the opposite of y deals with a positive 5, it's going to be a negative 5 when we talk about the actual y. Or you can go through and just divide each term by negative 1. When we plot this, we're actually down 5. 1, 2, 3, 4, 5. We'll go down 3 and right 1. We'll also go up 3, left 1. So it should look something like this when we're done. Something that I always like to note with the graphs, when you're done with your graph, I want you to check it really fast, okay? Here's how you check it, okay? You look at what your y-intercept is, which is negative 5. Okay, there's negative 5. That's where this physically intersects here. And secondly, it has a slope of negative 3. The way that you check this is you just say, well, is my slope going down? So from left to right, am I going down? If you are going down, you've probably done it correctly, hopefully. Again, over here, slope is, or the y-intercept is 4, so we're up 4. And our slope is going down, so I think we're doing okay. For the first one, we're up 5, and we have a slope of negative 1, so we are going down. I just check to see whether it's positive or negative if I'm going in the right direction. Since all of these slopes are negative, that's negative 1, that's negative 2, and this is negative 3. All of our slopes, our lines should be going down from left to right. Does that make sense? Yeah, okay. Next one. And maybe this gets just a little bit more complicated to solve for x, or solve for y. We'll see how this turns out. What's the first step that we do for this one? Okay, subtract 2x. So we're always subtracting the x term. It's always our very first step. So we'd have negative 4y equals negative 2x plus 8. Then what do we need to do? Well, this says negative 4 times y. So what's the, we have to divide. So we divide this by negative 4, divide this by negative 4, divide this by negative 4. That'll cancel, and then we'll just leave it left with y on the left side. What's negative 2 divided by negative 4? It's 1/2, isn't it? Yeah, okay. And then 8 divided by negative 4, it's going to be negative 2. Okay? So all we have to do is we just basically simplify those fractions. And I think it's always good to keep that as a fraction as opposed to changing it into a decimal. The decimal is really going to be confusing when you try using rise over run for this. Okay? So to plot this again, we're down 2. I think you guys are getting pretty good at this. And we rise 1, but we go over 2. Rise 1 over 2 until we fall off the page. We go down 1 and left 2, down 1, left 2, until we fall off the page here. Something like that. I think I missed a dot somewhere in here. It looks something like that. Is everybody okay with that one? That was a little different just because there's something in front of our y. So as we go through, we continue to subtract the 2x from both sides. Then we divide each side, every single piece, each of the 3 pieces by negative 4. Simplify the fractions, then we should be good. Okay? Tyler, help us with the next one. What do we have to do? Subtract x from both sides. What do we get? Sounds good to me. Now what do we do? For each thing, right? Okay, what does that give us? Y equals 3 is not correct. These are both would be, the negatives would end up canceling. And x over 3 is the same thing as saying 1/3 x, isn't it, Tyler? Does that make sense? Okay, and what do I do with this 9 divided by -3? You get -3, okay? So that's -3 there. Okay, we're just simplifying these pieces. I think this is really pretty good for you guys. So that would be a -3. We will rise 1, but we'll go to the right 3. Rise 1, right 3. Rise 1, right 3. We'll go down 1 and left 3. Down 1, left 3, and down 1, left 3. Until we fall off the page. We draw a straight line through each of those dots. Draw little arrows at the ends. Hopefully yours looks something like that. You guys are using rulers, so hopefully yours are better than mine, but it's about where we're at. Yes, sir. Okay. Sure. Janelle, what do we do with this next one? Mitchell, I don't want that on my desk. Subtract 3? Oh, subtract 3x from both sides? Okay, what do we get? Sounds good to me. Now what? Divide everything by the 5, not 5y, but 5. Okay, and what are we left with? Yeah, and that's perfect. So -3/5, which is totally fine to leave it just like that because it's a fraction that gives us rise over run. It gives us our slope. It's fine. And just the +2 should be fine. Okay, so the +2 means we just go up 2. Our slope means we go down 3 and left 5, so down 3, left 5. Down 3, 1, 2, 3, left 5 would be right there. We also use the opposite slope, so we actually rise 3 and go left 5. Rise 3 and go left 5. Should get a slope that looks like this. Hey, show of hands, how many people think this is really easy? Excellent. That is good. If you are struggling with this at all, I do want you to ask some help today in class. I really think that would be helpful for you and your grade. I'm going to pass out, again, 12 graphs. I do want you to graph these. I think we could probably get this done in class, but it will be due tomorrow. Your substitute will actually walk you through grading this. I'll be gone tomorrow because I have a dentist appointment in the morning. And then on Thursday, my wife and I are doing something special, so I will also be gone away from school. So I will not see you until next Tuesday, which is forever away.